Hello guys, today we will look into the Azure Service Bus Emulator integration with the Kubernetes using the simple C# example. We will also look into the configuration of Azure Service Bus Emulator, and for that I have used the infrastructure tool Docker Desktop and Minikube. Okay, so I have used the Microsoft SDK using the .NET 8.0, and I have used the libraries Kubernetes client library, Azure Service Bus library, it is there. Newtonsoft JSON, it is there. Okay, so we will look into the now we will look into the Azure Service Bus emulator configuration file. It is there. Okay, so this is typically Azure Service Bus configuration file seems to be there. So you have to specify the namespace here, and then you have to specify the queues. We are not going to interact with the queues, so we will omit this one, and we will look into the topic directly. All right. So we have created one topic along with the all the properties there. Here it is the ISO 8601 timestamp it is there. So this is typically for this is specify the time 1 hours it is there. When you specify the T here, it is the time it is there, and this is the time for 20 seconds. Okay. So we have created the subscription here, subscription dot one, and same we have done for the other subscription also. Okay, this one. Okay, so this configuration file should get mounted onto the volume. So I copied this folder into the D drive there and specified that location into the this one here, and I have specified this location into the code. So we will go through into that one. Okay, so but here I have used some configured service bus emulator. So for that one, I simply created one Docker file. I just rather than going to the volume mount, I just copied that config.json file to the this emulator folder. Okay. Okay. So I have created this Docker file based on the Azure Service Bus emulator, and you can specify the environment variable if needed there. And here we have to expose these two ports. Okay. Basically, we will interact with this one only. Now let's look into the code now. Okay, so this is the program.cs. Okay, I have created one Azure Service Bus example here, and here I have created the function build Azure Service Bus that is been called from the program. Okay, so this is the deploy Azure Service Bus. I have specified the namespace, and it is the pull policy always it is always there. I have specified the deployment name, pod name, or service name it is there, and here it is the app value. It is used for the selector purpose. Okay, I have specified the replica one it is there, and the port that we have to communicate it is there 5672. Here it is the simple Kubernetes client I have created that we will go consume into the next function, this function. Okay, so I have gathered all the means pods, services, and deployments over here, and I have deleted all the respective pods and services deployments if it is there already created. So means we will create it is in new fresh pod and deployment. Okay, so this is how we have to create the deployment. Okay, so rather than going to the YAML, so this is the good way to achieve that one. Okay, so we have to specify the kind over here, then we have to specify the name, deployment name that we have created, we have specified here. Okay, and this is the one we are specifying the deployment specs here. Okay, so the replica here I have statically marked as one, and this is the selector one. This selector we will use in the services to match the labels. Okay, so this we have to keep in mind. This selector should be matched to the services target there. Okay, so this is the template specification, it is there, and here we are specifying the label. Okay, all this should be in sync. Okay, this one app value, this one app value, and this ones when you create any service there. Okay, okay, so now there is some dependency over the SQL edge, it is there. So I am going to create the containers in this in the pod. Okay, so we have to create the image, we have to pull the image for the SQL edge. Okay, here I have created one pod that comprises two container. Okay, this is the one container, it is there, SQL edge. Okay, and here we have to specify the SQL password. Okay, it could be anything. Here I have specified this one, and I have specified the environment variable, the accept EULA. Okay, okay, so now this is what I have configured this image earlier based on the Docker file that we have seen there. Okay, so in this case we don't have to mount any volume, and we don't have to take any risk for the mounting any volume that could fails. Okay, so I have created the image, and I have pulling that image from the Docker Hub. All right, here I have specified the host IP and this container port, and this is I am specifying the name for that container port. Okay, and this is the host port over here. Okay, basically we are communicating only through this one, 443 it is there, and other you can omit other if you don't need. All right, I have specified the here image image pull policy, it is always. And now coming to the furthermore, I have created the deployments over here. Okay, so means another one important thing, you have to specify the SQL server for this emulator, where your SQL server is being mounted in the services, it is endpoint. Okay, so here I have specified the SVG SQL edge. It means we have to create this service which is exactly name of this, that should get matched. Okay, the SVC SQL edge. Okay, then now we will come to the services here. So I have created the namespace service for the SQL edge, and for all the respective ports there. Here I have specified the target port, all the stuffs here. That target port should get mapped to the target port of this host port. All right. Okay, so here I am specifying the load balancer, and I am specifying the IP load balancer IP. It is the local that is the localhost IP. It is the 127.0.0.1. Okay, all right. So this is the I also have done same for the Azure Service Bus emulator. Okay, so this will be service for to interact outside the Kubernetes cluster IP. Okay, okay. This selector should get matched to the that selector that we have specified into the labels. match labels, this one. So the services will target to the that deployment. All right. So after that, we will check why how the means we will communicate to the our Minikube cluster. It is there. So we will check Minikube start. Okay, it is being started. Let's wait for it. All right. Okay, so meanwhile, guys, so Minikube exposes the load balancer through the Minikube tunnel. So we also have to start that Minikube tunnel, and we will try to delete all the existing deployments using the our API only. We will not do any manual things over here. Okay, Minikube tunnel. So this will help us to expose the our services to the outside the cluster IP, outside the cluster. Okay. Now let's see what happens if we run this application. I will mark this as a start project, set as a startup project. First we will check kubectl get deployment. Okay, this is the already the deployment is being hosted there. Kubectl get pods. Okay, pods also it is the running there. Let's see what is happening there. And it is the saying the age 13 hours. So we will look into the whether our application works or not. Yes, let's do F11. Okay, Kubernetes client it is available now. Okay, we have gathered all the deployments, all the services, and all the pods, and we will try to delete all those one. Okay, now let's see. Okay, so you can see that all are being terminating here. Okay, so we will move to the ahead. So here we have created the deployment object, and now we are executing this step for the creating namespace deployment. Let's see what is happening over here. Okay, you can see the deployment it is being deployed here, and it is saying the running, and the most important thing here age is 17 seconds. So means it is a freshly deployed. Now we will look into the namespace services. Let's check kubectl SVC. Only SQL age as of now it is there, and now we will try to see. You can see here the external IP it is being assigned there. Okay, and it is marked as load balancer. We will execute one more step here for creating the service for the Azure Service Bus. And this is the endpoint we will interact with through the application. Great. Now you can see here this is the one service it is being created. Okay. Now we will test all this deployment. To the solution, properties, multiple startup project, stars. We will create this publisher subscriber. Okay, so now let's try to understand how I have created here publisher and subscriber here. So let's close all the tabs. Here it is the entry here, and we will look into this extension. Okay, so here I have created builder, application builder, web application builder. I will go to this extension method that I have created. Okay, so this is the extension method I have created that will add the topic, and the connection string here it is always will be this kind of. So to understand the connection string furthermore, you can check the Azure Service Bus Emulator interaction connection string here. Okay, here we are configuring the Azure Service Bus client, and which will have the AMQP over the TCP. I have added this. Okay, so here we will also look into the subscription. It is the async, so it is triggered at the, here also. So this is the one here. Here message handler, we will look into the message handler also, and we will look into the add subscription here also. Here add subscription it is triggered. Here also I have created the Azure Service Bus client along with the connection string. So basically these steps are common for the publisher and subscriber. Okay, here the most important turning point over here that we need to understand the message subscriber, this class. We will look into this also. Okay, so here I am passing the provider here. Okay, and so when I passing the provider here, it will give the guarantee to available all the added services here. Here we will create the service bus processor along with all the properties. Okay, here it is the most common pair lock receive mode it is there, and we are going to create the receiver here, and this is the most important event that is we are being created here with the delegate. Okay, so this will receive the message, this will receive the message along with the argument message, and we have here deserialize along with our generate type. Okay, and we will also check whether the handler is being assigned or not. If it is there, then we have checked over here, and here we have processing that handler here, and we are completing it is Yes, we are completed. Stop here. Okay. And here the another one delegate we have assigned for the to handle the exception. Okay. So here start the process sync. Okay. Great. The process is start. It means it is connected to the our Azure Service Bus Simulator. Okay. Okay. So this is the publisher one, and here directly executed this get point, and now we will check message. Here we are configuring the message over here, and we are sending. Okay, this publisher. We will also look into the publisher how we have configured this publisher here. Okay, so this is the publisher, and the publisher here we are passing the provider and topic only. This is the add topic we were discussing here. Add topic, and when it will comes in here, here we will check the it come here. Type here it is DTO message from the publisher DTO message, and we are passing the hello over here. Okay, so we are just realizing, and we are creating the byte array for that one. This is the service bus message. It is the Azure Service Bus class, and we are marking it as a JSON to handle from the client to deserialize it. Get required service client here. Yes, service bus client. Create sender and send a sync. Great. Here this step is executed. It means the message has been sent here. Okay. Now let's see in subscriber handler what is happening there. Yeah. Here it comes there. This is the triggering point. So this is the subscriber extension, and here it is the most important. When this breakpoint when application reached here, it means you are succeeded. Here message string we are deserializing, and we are creating the we are checking the handler. If it is there, then process async, and great. This is the subscriber handler. It is there. You can see the hello world. It is there, and we are writing into the console. Or the other messages are being all the pending messages are being executed now. We will remove the breakpoint here, and we can check. Okay, we will also look into the okay, so it is some small technical glitch. It was there. It was executed, I think, multiple times. So whatever exception it is there, it will be get cached. Let's see in the console how it is looking. This is the minikube tunnel. Hello world. This is sent. This is the publisher. It is there. You can see there. This is the publisher, and another one it is the subscriber. Now let's see what is happen here. Another one it is. Yeah. Yes. You can see all the messages are being received here. Okay. Now let's understand the code once again. This is the publisher. Add topic over here. Simple, it is as much simple as created the service bus client along with the connection string. This connection string now you have to replace by the live connection string. That's all. Alright. So created the provider here. So it will give the guarantee all the means services are being invoked and it is means integrated into the service collection. Okay, so this is the singleton object for the message publisher. Now this is the generic type that we have specified here. Here it is there, message contract. This is the most important thing you have to specify here. Okay, so created the clients, cached the service bus client here, creating the publisher now, and we're creating the class level variable here to access the provider. Okay, here we have specified the class level variable topic, and we are using it is consuming into the for the create center. Okay, so I am serializing here. I am using the class for the JSON serialization setting. Okay, so I have done some reference loop handling here and I ignored all those one, and I am serializing the object now into the JSON type and converting into the byte array. I'm creating the message and a message for using the for that byte array. Okay, so here I am creating the sender for that specific topic using that client, and I am sending the message using that sender. This is how the as much simple as the sender stuff work. Now let's look into the subscriber. Okay, so first of all, here I have created one handler along with the generic type. So this is the message handler. Based on the message handler, we will look into that one. Okay, so this is the add subscription along with the generic type, and this is the connection string. This is the common stuff, same as publisher, and you have to specify, you have to replace this connection string with respect to your connections, whether it is a live connection string or localhost connection string. Created the provider here. I am assigning that provider through the constructor. Okay, so message subscriber for that message type. Here it is the creating the client, and here I am creating the processor based on the processor options, service bus processor option. And here I am creating the receiver, and here I am creating the, this is the most important stuff here. We have to assign the create the delegate for process message async. And now we will read the string and we will deserialize it, and we will try to catch the handler, and if the handler it is there, then that process async message method will get invoked, and we are marking as complete message async, so it will not get called twice if the message already consumed there. So this is for the to handle the error, and we are starting the process as soon as possible. to avail the interact with the process async. Now we will look into the how the handler will work over here. Okay, so this is the iMessage handler, and as you can see here, this will get invoked by the process message async over here, and we will logging into the console as a string. Okay, now how we can invoke the publisher methods. This is the controller. Here we have is the di dependency injection here to access the message publisher, and you can see this message publisher is nothing but add topic and added to the topic here. This is the important. Okay, so we will able to access message publisher over here, and this is the important execution line it is there. Okay, and that's all. Now you are good to go to communicate your microservices to each other through the Azure Service Bus Simulator. That's all. Thank you.